Hey team, we are looking at the Hardy-Weinberg equation today, looking a little bit at how we can predict genetic frequencies within a specific population if we know how many individuals in that population are homozygous recessive. Basically, homozygous recessive are the only ones that we can tell. For example, if an animal, in the previous examples that you looked at, an animal could be black, but we don't know if it's big B or big B, little b. But we do know that an animal that's red is little b, so that helps us. So this equation is going to help us look at how many are heterozygous dominant versus how many are homozygous dominant. Punnett squares tell us what should happen, but statistics don't always work the way they should. For example, if you were to flip a coin 50 times, you might not always get 25 heads and 25 tails, just because the real world is messier than statistics make it look. This equation helps us look at a population and predict traits based on the recessive alleles that we see. Alleles are versions of a gene, so if we know that a certain percentage are little a, for example, knowing that can help us we can use this equation to help us figure out how common each allele is within a population. So this can help us predict genetic diseases, for example, and figure out how many people are carriers within a certain population. So I'm going to walk you through number one. You have 5 problems on this worksheet. I wanted to give you enough that you could practice, but not so many that it was overwhelming and impossible. So I'm going to walk you through number one. Within a population of butterflies, the color brown, big B, is dominant over the color yellow, little b. And we know that 36% of the butterflies in this population are yellow, which means 36% of the population of these butterflies in this population are little b. Given this information, we're going to calculate the following information. So we're going to start with the frequency of the little b allele in our population. So, looking at our Hardy-Weinberg equation, we are going to start with this one. So, since our little b allele is going to be q, we need to find q. So we know that q squared is going to be our little b. So that means in order for us to be able to find q, we need to square root 36. So I'm going to do the square root symbol of 0.36. Square root of 0.36 is 0.6. Okay, so the next question looks at the frequency of the big B allele in the population. This means that we need to find P. I don't know why I just wrote P on the board, but whatever. So this time we are going to look at this calculation. P plus Q equals 1. So I know that Q equals 0.6. So if I take 1 minus 0.6, that is going to give me 0.4. The frequency of our homozygous dominant genotype. So our homozygous dominant genotype is going to be P squared. So again, we need to go back to our P squared plus 2PQ plus Q squared equals 1. So I'm going to take my 0.4 square it. 0.4 squared equals 0.16. Okay, or 16%. Frequency of the heterozygous dominant genotype. So, looking at our P squared plus 2PQ plus Q squared, our heterozygous dominant is going to be 2PQ. So I'm going to take 2 times my P, which is 0.4, and my Q, which is 0.6. And that is going to equal 0.48. Hopefully that helps a little bit. If you have any further questions, please let me know. As these questions keep going, they get a little bit more complicated. Make sure that you read them carefully.